So with this example problem, we are once again taking a quadratic and dividing it by a linear factor, and we'll get a remainder here. So let's set this up as a long division problem, or a polynomial long division. So we'll put the term we're dividing by, the divisor, on the outside, and we're dividing into this quadratic. So that's x squared plus 5x plus 5. And notice we have all of the terms, so we don't have to put 0 of anything. Or in other words, we have the quadratic, the linear, and the constant term. So if we were, say, missing the linear term, and this was just x plus 5, we'd have to write it as x squared plus 0x plus 5. So if you're missing any of the terms, you need to put a 0 of that term just to act as a placeholder when carrying out the polynomial long division. So to start this problem, remember we're just going to ask what would we multiply x by to get x squared? And we're just going to multiply by x. And then we will actually carry out that multiplication so that we can subtract and find a remainder. So x times x, that's x squared. X times 3 is positive 3x. We subtract now to find the remainder. And we'll put parentheses just to remind ourselves that we're subtracting this entire expression. X squared minus x squared, that's 0x squared, which is what we'd expect. And then we take 5x and we're subtracting 3x, so that's 2x. And we bring down the next term, which is plus 5. So now we repeat the process with this new expression here. So how many times does x plus 3 go into 2x plus 5? Or how many whole times? So to answer that question, we just ask in a different way, what would we multiply x by to get 2x? And we'd multiply by 2. So now we carry out the multiplication. 2 times x, that's 2x. 2 times 3 is positive 6. And we subtract to find the remainder. And the 2x terms cancel each other out. 2x minus 2x is 0. And 5 minus 6 would give us negative 1. And since there's nothing left to bring down, this is our remainder. This is k from the problem description above. So we can say that when carrying out this division, we get x plus 2 and then minus 1 over x plus 3. Or you can say we're adding negative 1 over x plus 3. So either way works there. But you always take your remainder and put it over the divisor, whatever the linear factor is here that you're dividing by. So this should be our final answer. Now, if we want to check this, remember we could just multiply everything by x plus 3. So you would distribute the x plus 3 into all three of these terms. And after simplification, if you get back the original quadratic in your numerator here, this dividend, then you know you did it correctly. So I'll leave that as an exercise that you can attempt and check your work there. Since with all of these problems, if you do have a way to check your work, you should do that. You should practice checking your work just so that you can be certain whether or not your answer is correct.